Grids are becoming the bottleneck of the energy transition. Unless we use the full power of software, we won't be able to keep up with the change.
Your trusted source for information on the energy transition. This is the Insider's Guide to Energy podcast. Hello, Energy Leader. This is Chris Sass, host of the Insider's Guide to Energy, and I asked for just a few moments of your time to make you aware of a brand new program that I think you'll be excited about. The program is called Podcast Power, Media Training for Energy Leaders. You're probably already aware that podcasts are a dominant force in the media today. As an executive in the energy space, you are often asked to be a guest on a podcast, and your legacy media training leaves a lot of gaps in the skills you need to be successful on a podcast. Common sense doesn't always do it. And to avoid these pitfalls, Insider's Guide to Energy has partnered with the Antenna Group and their media trainers to create a hands-on interactive 2-day workshop designed for executives in the energy and clean tech space specifically. You'll get all the skills you need to have successful interviews and to reach the audience you intend to reach. So whether you're reaching out to customers, future employees, or investors, this is the class for you. Space is limited to the first 10, and those that are selected will get the opportunity to be a guest on the Insider's Guide to Energy, practicing your new skills. Welcome to another edition of the Insider's Guide to Energy. I'm your host, Chris Sass. With me is my co-host, Jeff McCauley. And today we have with us Sabine Erlinghagen, the CEO of Siemens Grid Software. Sabine, welcome to the podcast.
Welcome. Thanks for having me.
I'm excited to have you here. I'm always a sucker for software. And when it comes to making the grid better, we all know there's a layer of software that needs to be developed. And it sounds like your organization's working on it. Why don't we start by what is Siemens Grid Software?
Siemens Grid Software is all about helping grid operators plan, operate, and maintain their grids in a better way and using the full potential of software. And that's specifically important given all the challenges that we see with the energy transition. Certainly the need for grid capacity, both in the transmission grid as well as in the distribution grid. But then more importantly, even the distributed energy resources and this complexity that comes with it for both grid planning, grid operations, and maintenance.
Let's start on the grid planning and operations side. Sabine, you are very well aware one of the biggest challenges in the renewable energy world today is really about interconnection. How can software help speed up the interconnection process?
The interesting thing about interconnections is that you need to give an answer of yes or no whether something can still come onto the grid. And most of those decisions are actually based on no data or on statistics and theoretical load curves and assumptions. So I think the first thing that you can do is provide transparency and understand how much can your grid still take on. And that must be a data-driven decision. And our software Grid Scale X can help you do that by understanding how loaded a transformer is already. Like how much of a risk do you have of overloading that? And if you then still connect, what can you do in terms of flexibility management to allow it to come on under certain conditions and then act upon them? So I think it's a terrible news to know that 2,000 gigawatts worth of interconnection requests are actually queuing at the moment. And we have very poor data to do those decisions. And typically, because we are risk averse, we say no, even if we could still say yes.
So are you planning an infrastructure where we can oversubscribe because you understand the impact of the oversubscription and then you can control the demand? Is that what the vision is here, to buy some time?
I think that's a very good way of putting it. Yes, I think the N-1 principle is something that was born out of a lack of better data or better knowledge or better manageability of the actual load. And if at the moment we put so much buffer in it that we can't afford that in the future. And I think software has done in other industries with airplanes. I mean, you run airplanes no longer on 4 engines just to be safe. You don't have factories creating a lot of waste and having a spare production line next to it. Software has solved all of those problems. Why shouldn't it be possible to solve that with for the grid?
Do we need every device to register with your system in order to be understood, or can you divine this from the way the traffic patterns are and knowing what I'm planning on connecting to?
You hit the nail on the head. The software actually disaggregates the information from the meters and knows with high enough certainty what's behind the meter and what are the patterns that you conduct from it. And it learns how much of that load, be it from an EV vehicle, if it comes from a solar panel or so, how much of that load is flexible and how much you can act upon with which means. And based on that data and that probabilistic learning, you actually then are safe to act upon it. And it's, as you said, it's not a putting out more sensors game and wait until you've rolled out masses of sensors, but it's a game of disaggregation. It's a game of AI and the understanding the patterns and then acting upon them.
This makes sense. So Sabine, basically what you're describing is we have a grid that in many cases is overbuilt, and we have to rely on that safety factor because we don't have visibility and we don't have flexibility. But when you add that flexibility and visibility with software, it enables you to run more efficiently, more confidently within tighter control parameters. What does that get your utility customers? What are the outputs? So we talked about maybe a faster interconnection process. What are the other benefits that your customers might see?
I mean, certainly we see that you can actually add 20 to 30% more to the grid than you would do with previous methods. Secondly, if something is happening, you know how to counter-react, and you have different layers of counter-reacting. And if it comes to the worst case of a low voltage or distribution power outage, then you can react on those much, much faster and restore it much better. And in the end, it brings down cost because you can utilize your assets in the field better, and you can make sure that the lifetime of those assets are longer. Because if you overheat a transformer too many times, and especially for too long of a period without knowing, then you run those things to an early failure. And that's a big problem, because if you look up the lead times or supply chain times for distribution transformers these days, you won't want inadvertently to run down too many transformers, run out of stock, and then wait for 2 years to repower your home. So you better know in advance, you better understand the risk, and you control it with dedicated actions.
Can we talk about some case studies? What geographies, countries, or do you have specific types of use cases of distributed energy resources that you want to call to mind that illustrate what you're talking about?
So with Grid Scale X, we launched both for Europe as well as for the US. The cases are slightly different, as the audiences will be aware. We have the unbalanced grids, and we have balanced grids, and in Europe you have the low voltage grids, which are different topologies, and so the use cases are slightly different, but the software platform in essence is the same. So let's take the example of Norway, for example. Norway is known for its high density of electrical vehicles. So they are kind of living in the future that we will all live in already. And they have a huge problem with grid capacity. They say they need to double their grid capacity in 7 years. So if you think about it, you build a grid for 100 years, and then you need to double it in 7. So it's pretty clear that with a conventional approach of digging up the roads, getting the permits and whatnot, this won't be possible. So we are partnering with Elvia, which is the local utility for Oslo and the bigger region. And with Grid Scale X, we're helping them understand what's going on in their low voltage network, enabling those conditional connection requests and provide better customer service and get those connection requests processed really fast.
Wow, a doubling of grid capacity in 7 years does sound very challenging. What's driving that primarily? Is it EV adoption, renewable energy, load growth through electrification? What are the primary drivers there?
I would guess all of the above. I mean, the EVs are already pretty high, so they've kind of gotten used to it and learned to live with it. But there was actually even to the US press, there was an interesting incident. There was an ammunition factory who wanted to expand their capacity and get more power from the grid. And at the same time, there was a TikTok data center going online. And since TikTok was faster, the ammunition factory had to wait for the connection request. And that made it, I think, even to the Washington Post.
And that's an American use case you're saying that happened?
No, that was Oslo, and it made it to the Washington Post.
It's in Oslo.
Because it's about the Ukraine war and the ammunition factory kind of wanting to produce more for Ukraine. So those are kind of, I think it's a very, like, Norway has become very attractive for industry, for data centers, for like all kinds of industry which is energy intensive, and they just are prosperous, and that leads to higher electrification levels faster, and hence you have the grid capacity demand.
What is the North American story happening? You launched in multiple continents. We all know power runs differently and the infrastructure is set up differently. How is North America using the software or planning to use your software?
Mm-hmm. I mean, first of all, North America has done a great job in rolling out smart meters, and has also done a great job in kind of building data lakes and trying digitalization strategies. But what we're missing is making sense out of the data. And for meter data management, or meters, making more out of the data than just, in inverted commas, the billing process. So metering is still meter to cash. And we've embarked on all those very heavy lifting digitalization processes. And with Grid Scale X, the approach is to do that more lightweight and to have the data understand or be interpreted in the context of the grid topology. And what that does is, and I think Peter Kelly in one of your previous podcasts said it, like, yes, you have meter data, you have that's around for some time, but people can't interpret it and can't do anything with it because they don't know what it means for the assets, for the distribution transformers, and what's the financial impact of not consuming energy, of connecting more, or replacing ahead of time or later. So we can't quantify that yet, and our software helps to do that. We created a pretty sleek thing called the Grid Impact Score, which on one view on every level of topology of your grid tells you how loaded your grid is and where you run a risk of overload and where you still can add more capacity. And that's like solving a pretty big problem, which people haven't even started to try to solve because it's so heavy lifting.
Sabine, you mentioned visibility into the problem, but you've also hinted at taking action. So what kind of actions can utility grid operators take with this new visibility?
Yeah. I mean, if I have a high grid impact score, it means like I have more frequent or higher overload situations. So I can, in my asset management department, I can actually change the cadence of how much like when do I replace an asset. And secondly, which is the even smarter solution, is then align that with your demand response programs and actually incentivize people to use less on certain times, and then really in real time react on the situations that you see on the grid. And you can target your programs to those areas where you really get an overload situation, and you can make more precise connection approvals and admit more to the same existing grid.
Now, Siemens, traditionally, have you been known as a software provider for, or more of a hardware manufacturer in the space?
In grids, we've been around with software for a long, long time. So 70% of the world's electrons flow through grids that are planned with our software. So most of the US plans with our PSSE software suite. So that goes back a very long time. If you think about Siemens overall, obviously we have also a very significant hardware footprint. But when it comes to grids, we are really in software for a very long time, and we've come the same traditional way than most others. So we started in having very sophisticated methods for managing transmission lines, both in the control center space as well as in the planning space. And the attention these days has shifted clearly to distribution. And what we figured is you can't just take the paradigm from transmission down to distribution, but you really got to rethink that and rethink it from the bottom. And since we traditionally also have a very long history in meter data management, that was a quite natural step for us to flip it on its head and say, what can we do with the data that we have already, and how can we overlay planning and operations functions in one modern software platform? So we took quite a radical innovation approach to that one and not just continued what we've been doing for the last 20, 30 years.
And how did the market receive this kind of change in the paradigm? I mean, utilities tend to be slow movers. How is it being received?
I think everybody acknowledges that we need to take a new approach. I mean, there are so many projects, call them DERMS or whatever, that have not gotten the results that were expected. They take ages and they cost a fortune. And then they don't realize the return that you had anticipated for. So our approach from the get-go was to do something that is fast, that creates value fast, and within weeks, you generate the first value out of our cloud-based software, and you can start gain transparency and gain that actionability that I talked about. So there was quite like a DTEC, it was quite well noted that we took a pretty radically different approach to the conventional ones. And as you said, I mean, it takes time to adopt because nothing is fast in our industry.
Have you seen a dramatic decrease in interconnects from timeframes for the folks that have tried your software? Have you actually seen it ripple out to real world shortening of interconnect timeframes?
Certainly people dare to connect more and I think have better data and reconfirmation to do that. So that's clearly there. And I think the first acknowledgement that we see is that it's really heavy lifting for them to get their data clean. And we've a very nice approach of making that heavy lifting an easier one to start with. So already in that process of getting your data straight, you learn a lot, and you know that you're not making an error in the end when you admit something to the grid.
Sabine, you're talking about the arc of history, and Siemens has been active for a long time. You've had a long history with Siemens, also have a stint at Internoc, now NLX, before returning to lead the software group at Siemens. What have you seen in the arc of your career to date? And can you give us a hint about what might be around the corner?
The beauty of what I've seen with Internoc, which by all means was still a startup or at least a small company when compared to Siemens, is that you can build things very fast, and you can innovate and revolutionize a market very fast. So I had the chance for Enernoc to be in Switzerland and really pioneering the demand response paradigm in Switzerland at the time. So that's like 10 years ago by now. Oh, time flies. But I mean, I think that knowledge of like knowing having the power of a big company, but the attitude of a small company is what can drive a big change. Because at the moment when I talk to utilities, be it TSOs or DSOs, we are all still underestimating the pace of change. Somebody said once that the utility industry is one where everything happens in the next 3 or 5 years. So whenever you ask, it's the next 3 or 5 years. And that was a decade-long truth, or several decades. Now, it's actually happening much faster than anybody thought. So when you think about connection requests, I went to Estonia, and they told me they have 10-folded their connection requests in 2 years. Or when you talk to some executives at DSOs in Europe, that you ask them like, how many more connection requests could you process with the way you're doing it today? And you ask like 2 times, 3 times, 4 times. They say, no. And then I say, you know that DERs will go up 7x until 2030. So all of a sudden we have a momentum and things are getting faster than expected. And that was not the case for a very, very, very long time. So you have been an alarmist if you have said, like, oh, this is coming. And now it's coming faster than you would ever expect. And I think that is something where you gotta be ready and you gotta act, because those exponential curves, they're tricky, right? They go after a while, they have so much momentum that it's impossible to keep up unless you've prepared for it. And that's what we've done the last 3-4 years. We've seen that coming, and we've invested massively in making things easier and faster. If you think about how utilities procure today, I mean, you have an RFP, you make a selection process. So this easily, the procurement process takes 2 or 3 years, from the initial idea of you want something to then actually making the award and the procurement decision. And then start implementing something like a DERMS system or an ADMS, and that takes you another 5 years. So 6, 7, 8 years into you want to do something, you realize the first value to know that you've missed like 8 years of innovation in between. So this is something that can't go on. It's impossible, because we will always be like half a decade or a decade too late with anything we do. So I think the industry needs to learn to get value faster, change faster, transform faster, with the risk of like incremental, or not the risk, but with an approach of incremental value and incremental step. It has worked in any other industry in the world. It's just because of the regulation and the paradigms that we have in our industry that this hasn't happened yet. And given the dynamics that we see and the pressure that will rise from, like, be it the effects of climate change or the attempts to avoid it, it's something inevitable. And that's like our ambition, to be that partner who can evolve and act faster than anybody else.
You have 2 parts to the solution. You have a planning phase, and I think you covered that fairly well, the problem statement of what planning takes today. And then you have an operational component of this. For folks just getting engaged with your platform, what's driving the immediate need? Is it the planning that they're hoping to get ahead, or is operations saying, hey, we need a better tool?
It's a very interesting question. And I think it's very much dependent on like the internal setup of the utility, or where's the bigger problem. And so like circumstances can decide what is the bigger problem. In the end, our conviction is you need to tackle both simultaneously, because if you don't plan with the same data and the same assumptions then you can act upon in your operations, then you get a problem, because the whole thing about flexibility, the probabilistic view on flexibility can't be acted upon. So you've planned with this is just enough capacity, and then you see in your operations that you have a problem. So unless you get that lined up, you won't succeed in that world. Where do we start? I mean, we started from both sides, to be honest. And the interesting part is then working with our utility partners to bring those departments together. Because it's, hey, this is my tool. I've brought it in for operations, and then this is not for planning, this is not for operations. So you have very interesting internal transformation processes that you're witnessing, and that we can help facilitate by saying, hey, this is the same underlying platform. It just once gives you the grid impact score, and here you get an outage management process. But it's the same software. You just click on a different view, and you get more a real-time perspective as opposed to a longer term perspective. And especially where you have CIOs coming in, or C-level who has a pretty bold vision on digitalization, this resonates a lot.
Yeah, Sabine, you've touched on a few different categories of software, whether that's DERMS, Distributed Energy Resource Management, ADMS, Meter Data Management System, MEMS. Are these creating false silos? You haven't really talked about individual separate categories. You've talked more about an overarching platform that can do multiple different things. Do we need to break down some of those silos, or do you think those are still important, separate individual procurements?
The answer is yes. I mean, in the sense of, do we need to bring down the silos? So we can leave it there. No, absolutely. Unless we have a digitalization strategy that goes across, it's not right. Obviously, there are different processes that each of those departments supports. But if you think about planning or operations, it's just the time frame that is different. Like the one is longer term, then it's getting to medium term, but you also simulate and plan in operations. You just do it daily or every like 15 minutes. It's just a matter of time perspective. So that's why I don't make that much of a difference. But of course, the buying behaviors and the departments are still cut in that way.
All right. We've talked quite a bit. We're coming up to time here, but I do have one more question, which is, how much is the current AI revolution enabling your platform, or could we have done what you're doing a few years ago? Is AI really fundamental for what you're talking about?
I mean, AI is older than ChatGPT, so we are using AI for a while, especially to, if you take metadata, I was talking about that. So does it need to be real time, or is it good enough to estimate the periods in between, or the time lag that you have given a trained model and so forth? So there's certainly algorithms that we use for a longer time. Also the disaggregation, we were talking about that, like not needing sensors, but understanding what's behind the meter, and overlaying that to grid topology, or building the grid topology and making that easier based on suggestions, is all things that are powered by AI these days already. So if you consider AI being older than ChatGPT, then the answer is yes.
No, I consider language models newer technology, but the chipsets, there's been a huge amount of money and effort going into AI, right? So machine learning, neural networks have all been around a long time. I mean, I did those in graduate school long ago. However, there has been a big push, and a lot of resources going into it. So the one thing that I always think about with utility is scale. So I spent a number of years working in telecom, and doing things at scale is hard. And utilities are scale. When you start talking about meters and the numbers, that's big. So I was just curious if there's some technology event in the last couple of years that has really enabled you to offer something that maybe you couldn't have offered in the past. That's all I was asking.
I mean, certainly cloud technology and the data processing that you see there is something that is fundamental. And to work with unstructured data is something that is today much easier done than previously. I think that more than a technology challenge, it's a mindset challenge on how you approach these things. And the way we've done that is by mixing people quite a bit. I mean, we have years and years and years of domain know-how in grid planning and grid operations. We run a lot of grids, both on the transmission as well as on the distribution sides around the world. But how do you challenge that, and how do you get to a vision of autonomous grid management in the end, where AI, where software takes over some of the decision making, makes recommendations, and automates a lot of the complexity and takes away the burden from the planner or the operator? And if to achieve that, you need paradigms to change, and that we achieve by mixing people from different disciplines and having them challenge each other and giving them the freedom to think without legacy. And then you use the technology that is there, but I don't think that for grids you need to invent a specific technology. You just need to make use of everything that is there with the right mindset and with the right vision of the future. And my takeaway is that the complexity that we are seeing running and planning grids is something that a human being can't manage with the tools that we have today, because the data and the volumes will just explode, and the decisions that any individual would need to take are just way too many. So you need to go to semi-autonomous and then autonomous grids to be able to manage grids safely in the future.
Wonderful. Sabine, this has been a great conversation. We covered a lot of ground, from planning to operations to demand response in multiple different countries and grid environments. Thank you so much. Really appreciate the discussion today.
Thank you.
For audience, we hope you've enjoyed this content as much as we did making it. If you do enjoy this content, you want to hear more about the grid, please like, subscribe, follow us, and don't forget to leave comments in both our YouTube and our LinkedIn channels. We'll talk to you again next time on the Insider's Guide to Energy. Bye for now.